as an energy balance for biosystem. Module 11 Mass Flow through Ecosystem. Segment 2 Carbon Cycle. It's me, Lily, from School of Life Sciences and Technology, Institute Technology, Bandung. In the previous segment, we already discussed about the hydrologic cycle. In this segment, we will focus on the discussion about the carbon cycle. Carbon exists in the biosphere in four major compartments: in the atmosphere, hydrosphere or oceans, land, and living things. That can be seen in this figure. A common misperception is the atmosphere is the largest reservoir of carbon on Earth. However, the largest category of carbon reservoir is coal, oil, and natural gas, as can be seen in the previous table. The IPCC estimates that carbon in the atmosphere increased from approximately 280 ppm during the pre-industrial era, or in 1770, to 379 ppm in 2005. And this increase is responsible for an increase in radiative energy in the atmosphere of about 1.7 watt per meter square. The rate of CO2 pulls to the atmosphere from the fossil fuel combustion has increased over the past 20 years by as much as 30%, as we can see in the previous table. The IPCC estimated that half the increased mass flux of CO2 into the atmosphere can be assimilated within a couple of years, 30% can be assimilated over 30 years, and the remainder will cycle in the atmosphere for thousands of years. And the rate of cycling are controlled by a mass exchange rate between major components of the global carbon cycle. Carbon cycle through the biosphere through the three primary processes. The first one is assimilation and dissimilation through photosynthesis in the biosphere. The second is the physical exchange with the abiotic component of the biosphere. And the third is the carbonate cycling through deposition and dissolution of carbonate compounds. Carbon cycling on land begins at NPP, as we can see in the figure B and D. Once assimilated on land or in the ocean, the carbon is ingested, sequestered, or excreted, metabolized, or mineralized, and a portion is returned to the atmosphere as the carbon dioxide, as we can see in the figure C and D. The ecological engineers design carbon sequestration ecosystem services provided by increasing NPP and soil sequestration. The carbon sequestration in soil as dissolved organic carbon or DOC and particulate organic carbon or VOC can exceed the rates of detritus respiration. So this process also increases other ecosystem services, including nutrient cycling, water storage, soil fertility, refuge, and many others. In the next segment, we will discuss about the nitrogen cycle. Until then, I'm Lily from Institute Technology, Bandung.